Last time I talked about a definite integral. This time we're going to go for an indefinite integral. The problem is that there's no Riemann sum equivalent in my personal opinion. So we kind of have to think of what a derivative is in the first place, right? And work back from there. Now, honestly, I don't know. So I tried to figure out the definition of it, but I couldn't. So, but first of all, let's go for a definite integral because that's easy, okay? That's easy. That's just bullshit. So, let me think. It is Riemann sum is equivalent to the summation of infinity. Oh wait, is this three? Okay, n equal one. Oh wait, this is wrong. This is so wrong. Limit of n equal to infinity summation n I equal one. The function of xi parentheses of this. And then this, if it's a bounded condition, equals b minus a divided by n. And also, we can actually do infinite. I just didn't do it because it's hard, but you have to use a uh, factorial, which is explanation point, which makes sense because you have a factorial, then you have n minus one, and then n and then continuously, and that you can do an infinite fractal there. And you can actually cancel out fractals and figure it out. It is not easy. I will say that. No, it's not easy. Of course, it's not easy. Um, I think the secret is, although if I were to do a f of x squared function, what will happen is that we have, let's just do a left hand because it doesn't really matter. Um, so it will be, wait, that's not x squared, that's the right way. So it will have x minus, oh no, a minus x squared. No, not x squared. Change of x parentheses square, which would equal change of no, xi, as we discussed. Um, right? Xi. Yeah, yes, that is xi of function. That's it. That's what I was missing. And then you would have to do an iteration of this, continued iteration of this, which is why you need ni. Oh, and also this will have I too. I, as you know, is basically n. If I remember correctly, that's pretty much it. Oh, wait, I'm wrong. I'm wrong. I'm so wrong. Sorry. Yeah, I. So I. Oh, we can actually move that. Cool. I is an iteration continuously. Um, Wow, I did not know this turned to one object. Cool. That makes things so much easier. I don't know how that happened, um, but that's cool. Okay. Um, Now, um, we have to look at a derivative. Not really, but I really want to look at derivative. Actually, we can look at a derivative function. That might be easier to look at. So, what is a derivative? An integral balance. Why does it work? Well, from what I see, is that derivatives are just slopes, right? Those slopes have number. If this slope is 4, 5, 6, as you go up, that in the the derivative gives you um, at, let's just say this equals t equals 0, so you get 4 over here as slope, and then 5, and then 6. Right, this is a linear thing. So actually, if this linear, this is the wrong function for a linear function. It should be something like this. Once it's 0, it's like that. So it's going to be, this point is going to be the reflection point, but we're going to say t equals 0. Anything before that is nothing. So we can actually get rid of this part. And anything before that is nothing. So who cares about that? Um, so this is a linear line. We got the we got something there. It's points, and then why would the area under here equal the derivative is the actual question, right? So if you think about it, you can do this. Let's just say you got a lot of data points and got the integral of that. So if you get this, you get the slope of it. So eraser. Imagine a slope field. Oh, I can do this, right? I forgot. A slope field. So at 1, 1, if this is 1 and this is 1, you can figure out what that slope would be from over here. Does that make any sense? No, it doesn't, does it? No, it doesn't make sense. Well, it's basically going to be something like this. The reason why is due to there being no plus c. The plus c determines where it is, but what happens is that when you take a derivative of something like x squared plus 2, you get rid of the 2, right? And you get 2x. So when you take the integral of that, you lose the information of the 2, so it turns to this grid format where you're not really certain where the plus c is at. So whenever you take an indefinite integral, you must do this. If you take a definite integral, it tells you the bounds, so there must be a true form of that. Um, so, yeah. That also brings into the question, how would you find the boundary point? Yeah, we'll talk about that later. If you were to have a boundary point, like if it starts like this, and then you only want the area of this format, um, actually, why would you want the area of this? It makes no sense. No sense. Yeah, that's pretty much it. Because I need to really review this section a lot more closely.